Okay, so we have this question here, and the question reads, just a moment. Okay. All right, so the question reads, find the volume of revolution generated by rotating the region bounded by the hyperbola. So the hyperbola is given by this here, and between the lines y negative 2 and y 2. So we have to find the volume there. So now, how do we find the volume? So when you look at this part of the question, what is being what is bounding this here is the what is the y-axis. So meaning that the axis of rotation for this revolution is what is the y-axis. And when you're dealing with the y-axis in this case, your volume is going to be given by pi. Then we're saying from A to B, those are the bounding points. Then a function that is going to be what in terms of f of what? F of x. And this here must be squared. Then this must be what? Okay, must be squared f of x like that. And because it's in the y, you must be what? Differentiating with respect to what? To y. So we write our what? Our equation there. So we have x squared minus y squared is equal to what? To 1. So in terms of x, this would be x squared like that. Then this here is going to be, okay, so this was supposed to be f of y because we're dealing with a function that is defined by x here. So that would be y plus 1 plus y squared like this. So if you are to write it in terms of x, that would be x, then the root of 1 plus y squared. Then we replace here, we have pi, then we are going, the integral, there it's from negative what? 2, then all the way to what? To 2 there. We have negative 2 and 2 there. Then replacing this here, which is there, we have root plus y squared, then we square this, then dy. So volume is going to be pi negative 2, 2 there. When you square this, the square root goes, and I just have 1 plus y squared dy. Then at this stage, we are just going to now integrate this, of course, respect to y. So this is going to be, okay, so this is going to give us volume equal to pi, then you have negative 2 to 2. You integrate 1, you just get y, then integrate the other one, you have y to the power 3 divided by what? By 3, like this. And because, okay, so here, this integral goes, because you've integrated, then you just have square from negative 2 towards to 2, like this. Now, because it's a definite integral, we have to now replace those values there. So we have pi there, then you have to replace, okay, so I have this part where I didn't erase this. So we have to replace in this here where y is. So you have to replace first by 2, then you subtract, then you replace what? Y. So you're going to have the first one where there's a y, you replace 2 plus there we replace 2, then that will be cubed over what? 3, then saying minus, then you replace negative 2 there plus negative 2 cubed over 3 there, then like that, and close it there. So this is going to be pi is equal to, then you have 2 plus that will be 8 over 3, then you have, this will be minus, there you have 2, then that would be, of course, negative there, then negative, since it's an odd power, negative 8 over 3. So you get that there, like this. So from there, you can continue now. on to say that is just going to be equal to pi. Then you have what? You have 2 plus 2 plus 8 over 3. The negative, when you distribute that negative, it's just going to give you positive 2, then positive 8 over 3 like that. And here you can add that 2 plus 2 gives you 4. Adding the other one, you get, so that will be 16 over what? Over 3. Then you can now add these two. You have 16 over 3 plus 4. And that just gives you 28 over 3. So our final answer is going to be, this is going to be equal to, the volume is going to be equal to 28 over 3. Then you have your pi there multiplying, so that will be pi. Then, since this is a volume, so that will be cubic units, since you don't know what exactly they've given you. So you just say cubic units. So this is how you find the volume. Okay, then we have now the next question, which says we must sketch. So how do we sketch? So in order to sketch, here we must put into play sketching the same way we would sketch what? A parabola. So when sketching a parabola, you have this parabola here, which is x squared minus y squared, then equal to 1. So this is the same as this is over 1, that is over 1. And we know that what we have down there, you have this is being your A, and that there being your what? Your B. Then, which means you can find your C by saying C squared is equal to A squared plus B squared. And this is going to be C being equal to the root of, so 1 squared is just 1, plus another 1 squared will be 1. And C is going to be the root of what? The root of 2. So this hyperbola has its vertices, or its major diagonal in the what? In the x-axis. So it means that this focus which we found, we are going to have 1 in the negative, that would be like that, and the other one is going to be the other way, which is 2, like that. Then A here, we're saying this is going to be in the what? In the major axis, so meaning we're going to have 1 in the what? In the major, that is going to be -1, and also you have 0, and then you have 1 and 0, these being the vertices in the major axis. Then in the minor one as well, you're just going to have 0, -1, and you have 0, 1, like that. So these are going to be in the minor diagonal. Now, having these points, we can now sketch our solid of resolution. Then, so it would be like this, where now we are saying our major diagonal in this case is here -1, and you have negative what? And you have 1 there. Then up there you have 1, and up there you have -1. Okay, so this here, let me draw. So I'll draw a box like this, dotted like that, and like that, coming here down to that point, then like that. So this point here, then one other thing that I must take note of is my my asymptotes. So my asymptotes will be given by y is equal to b over ax. So b and a are just 1, and this means that y is equal to what? To x. So the asymptotes are just going to pass, they pass here. So yeah, I have dotted lines like this, going this way, passing through that point in the middle, going like that, or that way. And this other side, I'll have it dotted like that, passing through that point like this. So now I have those points plotted out. Then I have my what? Root 2. So which is my focus. My focus is going to be negative here, root 2, comma 0. Then I have the other one, this side, which is going to be root 2, comma 0, then to be like that. So after getting these points, of course that's my y and my x-axis, I'm going to draw. So from here where the vertex is, I'll start from there, then it has to follow closely to the asymptote, then also that side as well, like that. Then here as well, it is going to pass like that. Then it's going to go. Okay, so this is a rough sketch like that. Yeah, so these lines supposed to be something like this. Then you have that they've said you have an intersecting line, that is y is equal to r to 2 and y is equal to -2. So meaning I'll have lines that are going to what? Straight lines that are going to pass like that, and they are down, that's going to pass like that. So this is a solid of revolution, and it's rotating about the what? About the y-axis. So it means here when it's spinning like this, and to be making this form of a what? Of a solid, where on top you have a disc like that, like even there down like that, and to be spinning about this way. So this is how this solid of uh, resolution will look. Okay, don't know if there are any questions here. Uh, all right, let's move on to the next one. So the next one, it says find the tangent. This equation, we said we must use this equation here of a what? Of a line, which is y is equal to m x minus x1 plus y1. Then from there, what we need is, first of all, a point, which is there, x1 and y1, and they've been given in the question. Then the other thing that we need now is to find our gradient. And that gradient can be obtained by finding dy dx, or differentiating this equation and plugging in those points there. So if I have x squared plus xy minus y squared is equal to 1, I can differentiate this. To differentiate the first part, I get 2x. Then to differentiate this here, I see that there are two variables multiplying. So I use that. I'll use product rule. So I'll differentiate the first part, which is x, and I get 1. Then I'll keep the second part the same, which is going to be y, plus then I differentiate the second part, keep the first part the same. So my x will be like that. Differentiate y, and of course it's respect to x, so that will just be dy dx. Then there again, that will be 2y dy dx, like that. And that 1 is a constant, so that gives me 0. So I can factor out here dy dx from these parts that have the dy dx, and that will be x minus 2y. Then this will be equal to, I can then take the 2x and the y the other side, and they become negative, so that be negative y, like that. Then when I divide both sides by x minus 2y, I'll just get this here in red, which is dy is equal to that there. Okay, so then from here, what we do, we are going to, from here, we're going to replace. So my m is just going to be equal to, I can replace my y, my x there, which is 2. Then my y is just 3. Then divided by my x is 2. Then my y is 3. And this is going to give me -4 minus 3 and 2 minus 6. And that just gives me -7 over -4, and that is just going to be 7 over 4. So this here is my gradient. So that is my gradient. Now, what next do I do from there? After finding the gradient, I can now replace it in the equation there. So replacing it in my equation, I have y, my gradient is 7 over 4, then x, my x1 is just 2, so that will be -2, then my y1 is just 3. Then here, I just expand this, and I have x over 4, x, then that there will just be -7 over 2 plus 3, like that. and that should give me, so I have 3 minus 7 over 2, and I just get negative half. So this is going to be y is equal to 7 over 4x, then minus 1 over 2, like that. So this is what I'm going to get. Okay, then for the tangent, so this is the equation of the tangent. Now for the normal, what is different is the gradient. So the gradient of the normal is given by negative 1 over, so over this gradient which we found, over the gradient of the tangent. So we can replace that. Say we are going to just get, so when I replace there, negative 1 over 7 over 4, I just get negative 4 over what? 7. So this is the gradient of the normal, and y is just going to be negative 4 over 7, then x minus 2 plus 3. And this is going to be, expand that, negative 4 over 7 x, then that would be plus 8 over 7 plus 3, like this. So this is y is going to be equal to this. Then now I can work out that. So 8 over 7 plus 3, I just get 29 over 7. So this is going to be y equal to negative 47x, and this is going to be plus 29 over 7. If you want, you can multiply by 7 throughout, then you just get 7y is equal to negative 4x plus 29. And this is going to be the equation of the norm. So this is how you find the equation of a norm. All right, the next question is this one here, and question says evaluate the limits. So we have this first one here, which is the limit of x as we approach infinity. Then that is x squared to the negative ex. So here I can write this as the limit of x as we approach infinity of, so x squared, I can bring this e to the negative ex and write it down. That would be e to the what, to the x, like this. Then I can use a Hopital's rule here, saying I have a function on top that is differentiable, another function that is differentiable, and when I differentiate, I'll keep on differentiating and replacing until I get a suitable value for this here. So when you observe here, when you input infinity where there's x there, like this, okay, this here, you don't know what infinity squared is because you don't know what infinity is. So you have to differentiate that. So differentiate what you have on top. You have the limit of x. What you have on top, you get 2x. And down there, e of x, differentiate it, you just get e of x. Then you do the same, you continue. You do, when you replace there, you still have this here. 2 multiplied by infinity, we don't know what that is. Then you have the limit of x as we approach infinity. So differentiate that, you get 2, and you have e of what, of x here. Then we can now here replace infinity. So when we replace, we're just going to have, okay, this is just going to be 2 over e to the infinity, like that. This here, e to the infinity, is just going to be infinity. Then what we have then when we divide this here is just going to give us 0. So the limit is what is approaching 0. So that's how we evaluate that limit there. Next, we have that other one. So in this other one, you have the limit of x as it approaches 0, then over cos x, like this. Then you have in the power there, you have 1 over x squared. Okay, 1 over x squared. So this is what you have. Now, I can say let y equal to the same function here, 1 over cos, like this, then 1 over x squared. Then I can introduce ln on both sides. I get ln this side, introduce ln here, then I have cos x over 1 over x squared. This is a power, and according to logs, I can now drop that power. I can have 1 over x squared. Then there I'll have ln cos x like this. Then, as you can see, that is just going to be ln of y equal to ln cos x divided by x squared. So I have this equation here. I can raise both sides to e. So when I raise this here to e and raise that there to e, this then just cancel out like this, and then I'll have y equal to cos x over x squared. So having this here now, I can write that the limit of x as it approaches 0 of cos x over x squared. Then now I can use L'Hopital's law here in order to what? To work out that. So I'm going to have here, when I replace 0 down, it will be undefined, so I have to differentiate. So I have the limit as x approaches 0. On top, when I differentiate, I get negative sine x. Down, I'll get 2x. Here, replacing 0 again to be undefined, so I differentiate again, then the limit of x approaches 0, that would be negative cos x. Then down there, I'll get 2. Then I can replace now here my 0. When I replace cos 0 is just going to be 1, so on top, I'll have cos 0 here over 2, and cos 0 is just 1, so I have negative 2 over negative 1 over 2. So this here is going to be the this is going to be the limit. All right. So now move on to the next one, which is here. And this next question, we use magic substitution in order to solve this question. So magic substitution, you have z equal to tan theta over what? Over 2. So you're saying z is equal to tan theta over 2. And when you work out this in terms of just x, like so we won't derive that part because we already did it in the other paper where we were finding that cos theta is going to be just equal to 1 minus z squared. Then we have 1 plus z squared like this. And the other one, which is dx or d theta, in this case is going to be equal to z2 over 1 plus z squared. Then you have dz there. This won't look at how to get these, but we looked at them already, so you can just revisit the video. So this is going to be the integral of where I have d theta, I can replace that. So I have 2 over 1 plus z squared, then dz here. Then down there, I have 1 plus, I'll replace 1 minus z squared over 1 plus z squared. So now we are going to show that this here, which we've just replaced, is going to be equal to the other side. So what do we get? We have that on top there. Okay, so the top part still remains the same. I have 2, 1 plus z squared dz. Then down there, I can make that into a single fraction, and I'm just going to still get 1 over 1 plus z squared. So I have the same thing here. So when I have the same, I can divide that, and that just gives me 1. And I have the integral of, I will just remain with what? Dz there, like this. So when I integrate dz, I'll just have, this is going to be equal to z, and of course, plus my constant c. So z is this one here, which is already defined, and I can replace that there. It's going to be tan theta over 2 plus c, hence shown. And this marks there end of this revision paper for test one. Do you have any questions?